Good morning, ladies and gentlemen. My name is Olena, and I represent Intellias company. We joined NDS organization just a year ago with the intention to contribute to the standard development. And a few months later, I joined the Goodyear SightLine project, and I was pretty enthusiastic about their technology, and at some point understood that this could be a good match. So today, through a comprehensive case study, we would like to demonstrate the synergy between NDS.Live format and Goodyear SightLine solution. We have a special guest from Goodyear here, Jonathan. I will invite him to the stage for a few minutes to give a short overview of what is SightLine doing. But just to give you an idea about SightLine, so through aggregating driving behavior, vehicle, tire and road information, SightLine is building ever-fresh curated databases to improve driving experience, vehicle performance, and of course, safety on the road. And our integration of SightLine solution into NDS.Live ecosystem is aimed to demonstrate how we can utilize vehicle conditions to improve accuracy of some attribute calculations. Of course, maps are vehicle agnostic in general, but in some cases, vehicle condition can impact attribute values. And here we will be talking about tire condition impact on such road characteristic as friction. Imagine driving on the dry road with a new tire and driving on the wet road with a worn tire. So the car for the safe drive will require completely different emergency braking distance, completely different safe speed values. And this is where our demo stands. This is a short overview of the architecture and the operational flow of the solution. So essentially everything begins with the car sending the REST request to the NDS.Live smart service. And this request we extend with the tire condition information. So we are adding tire type, tire tread depth in millimeters. This is a tire wear state, tire pressure, and tire load. Then the NDS.Live smart service makes a call to the Goodyear SightLine friction API, which in its turn calls the weather service to take the real-time weather conditions. And this data, friction data, then is packed into standard NDS smart layer, which is basically the well-known road characteristic layer that contains friction attribute. And on top of that, we are grabbing advisory speed limits from the NDS.Live database and adjusting those values to the safe ones according to our friction coefficients. This additional advisory speed limit layer actually is a road rules layer, so one more road rules layer. And then all this data is sent with the other map data back to the vehicle. Now we have a short video of presentation. It had to be a live demo, but yet to save some time. So we are making a call. We see here the tire type, tread depth 8 millimeters, which is a new tire, and the tire in Luxembourg. So this is for the rainy weather and +2 degrees Celsius, which is not good for a summer tire. This is a summer tire model. And now going through the complex, as Björn mentioned, complex and nested data structures of NDS to check the attributes. We see the friction attribute value is 0.69. And this attribute is also supplemented with the attribute source property artificial to mark that the value was derived by an algorithm. Yeah. And a road rules layer. So we have one more road rules layer that contains the adjusted advisory speed limit value. And we see that advisory speed limit is 56. Now I will open the map viewer to check the original advisory speed limit value to save some time. And this speed limit value is also supplemented with the attribute source type artificial, a well-known tool for everyone here, I guess. And we will see the road links soon. Selecting the road link and checking the values. So original advisory speed limit value was 70 kilometers per hour. We see here our friction coefficient. And the advisory speed limit recalculated for this weather and these tire conditions is 56 kilometers per hour. Now I'm changing the tread depth to 2 millimeters, which is a one tire. So usually the recommendation to change the tires is when it's 1.6. So we are close to that value. And let's see how the friction value and the speed limit value will change. In this particular case, we are getting weather data per tile, but there is a possibility also to check the weather data per road chunk. For example, for the smart layers, for the smart pass service, which will give more detailed information, but usually for the weather is not changing so much within the tile. So we see that friction value is 0.62. It's lower due to another tire condition, and the speed limit is adjusted to 49 kilometers per hour. And the next small video. The same conditions, so we have the same tire, the same tread depth, but this was grabbed on May 26, if I'm not mistaken, and there was a sunny, nice weather in Luxembourg. So let's check what friction values we will get here. So the same tile. And actually the advisory speed limit is the same one. And the friction coefficient, it's close to 1, which is quite good. And the advisory speed limit was not changed, so it's still 70 kilometers per hour. The speed limit model that we are using here is quite straightforward. It was based on some existing papers and open researches, but we also made some carless simulation to simulate the vehicle movement within a different friction trigger zone and to check if, to validate this model. So this is car moving with the friction 0.7 and the speed is 70 kilometers per hour, so it goes into a skid on a turn, right? So you're driving with a worn tire in the rainy conditions with the summer tire. And the next one, 50 kilometers per hour and the same conditions. Yeah, and here we have a safe drive, yeah. To highlight maybe some use cases that we see for this implementation. So first one is advisory speed limits adjustment, as I already mentioned. Another one is quite straightforward, is giving driver alerts before the low friction spots. Of course, it can be used for the operational design domain awareness for autonomous driving and for advanced driver assistance systems to adjust the cruise control settings or emergency braking distance and a lot of others. Of course, maps already incorporate standard friction attribute, but we would like to highlight this solution benefits. So first of all, it offers high precision because it's tailored to your specific tire conditions. It also allows smooth integration as we are using all the standard NDS data structures and layers. And the cloud computing, it allows to shift all the computational efforts to the cloud and let all the magic happen behind the smart service. And we have some evolution ideas here to, first of all, to enhance the advisory speed limit models based on some real experiments, because Goodyear SightLine possesses the experimental labs and all the necessary equipment to do this. Also to incorporate SightLine aquaplaning prevention model into NDS.Live database. Amend the routing service to take into account friction coefficient on the route. And of course, for eco-routing, it can be used to calculate more precisely the estimation of battery consumption. That is a short presentation. So if you would want to discuss, we have our technical brain Dmitro online with us, and we have here on site Sosha Kozora-Justin is product marketing lead from Goodyear, and Jonatas Lukas, whom I would like to invite for a few minutes just to introduce the SightLine solution.
Thank you, Elena. Can you hear me? Yeah, so I'm quite excited. Thank you for the invitation to be here. I think you might be wondering why tires, and I think you've seen live real application and use case. For those who understand a little bit of tires, they are quite complex and difficult to predict, and they are influenced by several factors. So Goodyear, with more than 125 years of experience, we have developed very advanced algorithms that can communicate with the car and can communicate with the driver. So our vision is really to become the foremost trusted provider for tire intelligence, so intelligence solutions, and that will make that road connection smarter, safer, and more sustainable in the mobility ecosystem. So you might wonder how we do that. We basically aggregate data, environmental data, everything that is weather, road related conditions. Of course, vehicle data, so we can communicate with the CAN signals of car and different requirements there. And of course, then our knowledge on the tires. And as you've seen from the example that Elena shared with you, there's quite a significant impact on braking distance. There's quite a significant impact on the speed limit that is recommended for a certain situation. And as the tires, they wear out, the performance of the tires and therefore the performance of the vehicle is going to change. So hence, that's why it's important to have a dynamic application of it. So here I'm just trying to speed up because I know we are behind the schedule, but a couple of examples on the use cases and applications for OE and tier ones. So anything that is related to customer experience, you can simply provide a warning to the driver. Or for example, if your tire is wearing out, we have accuracy at the millimeter level where we can tell drivers to actually drive back to a certain dealership and then therefore drive the revenue back to the dealership of your preference, of the OEMs, of course. We have everything that is performance and safety. So we are working with some OEMs and also tier ones. So by actually incorporating that layer and applying to ADAS applications. So how you can actually influence or advise the vehicle of the better speed, of the better braking distance. And I mean, just to mention also, we have, for instance, hydroplanning, predictive or detection algorithms that you can also anticipate potential hazards that the drivers might encounter in the road. And the last that Olena also mentioned, the Eco Optimizer, because we know the forces and we know how to understand the energy that is required for cars to drive, we can better help to estimate the accuracy of the battery range of our cars as well. So yeah, that's it. Thank you for having me. I don't know if you have any questions or, yeah.
So thank you, Olena. Thank you, Jonathan.